Right. So before we dive into the code, let's kind of think about what a node data structure is and how we can organize these nodes into a linked list. So a node is just a data structure that holds three types of properties. It holds a key, which for the purposes of this video will be an integer, and then it has a pointer to the next element in the list and a pointer to the previous element in the list. So when you first create a node, you just set these two pointers to null and you provide it the key, and that's it. So now we have on the screen two nodes. Their pointers are all pointing to null. And now we're going to talk about the first operation that we want to do in a linked list, which is going to be insert. So to insert an element in the linked list, all you do is you point the head pointer of the linked list to that new node, and that's it. Pretty simple. So if you want to insert, a second element into this linked list, what you'll do is you'll take that element, you'll point its next pointer to whatever head's pointing to, then you'll follow head, and whatever head's previous pointer is, you'll point that to the new node in the list, and then you'll take head and you'll point it to this new node so that it's again pointing towards the first element in this list. So using these pointers, we kind of follow them and point them to the new node that we want to insert into the list. The second operation I want to talk about is search. So once you have a linked list in place, maybe you want to search for keys in the list. So let's say we want to find 22. It's pretty simple. You just start at head and you see what head's pointing to. And if is head, it has the key that you're looking for, then you just return that value. Otherwise, you just you just look at the next one, and so on and so forth until you find the key that you're interested in. So that's pretty simple. That's search. And then the last operation I want to talk about is delete. So when you want to delete a element from a linked list, you first search for it based on its key. Then once you find that element in the list, in the same way we kind of manipulated the pointers when inserting a node, we're going to do the same exact thing when removing a node. So let's say we want to delete 22. We start at head and we find it using the search operation. Then what we're going to do is we're going to follow the previous pointer of 22, which in this case points to 19. And whatever it points to, we're going to take its next value and we're going to point it to 22's next value. Okay, so in this case, since 22 points to nothing, we're going to take its previous value and point its next value to nothing. Okay, then what you're going to do is you're going to take its next value and you're going to follow it to wherever it points to. In this case, it points to nothing. So we're done. So we kind of, just by manipulating the pointers, we just kind of spliced 22 out of the list. And there's a few edge cases that we'll get into when we start implementing the code. So those are the three operations that we're going to be doing on a linked list. Well, four if you count creating it. So we'll create the linked list, we'll insert nodes into the linked list, we'll search for nodes in the linked list, and then we'll delete nodes from the linked lists. Okay, so let's jump into it. All right, so I have a basic text editor over here, and then I got some notes over on this side where I've implemented a node data structure and a linked list data structure. So let me walk you through my implementation and kind of show you how these things work. So first what I've done is I've implemented two structs, one node and one linked list. The node just has a key, a pointer to the previous and the next node. Okay, and the structure of the linked list is just a pointer, a node pointer type called head, and that's it. Okay, so then, it might be nice to kind of, we're gonna have to create a node in order to test this. So let's create a method called create node, and it's going to return a node pointer, and it's going to take an integer called value. I'm just going to change this to key, so I like that better. So first thing we're going to have to do is we're going to create a node pointer called node, and we're going to initialize some memory, allocate some memory for that thing. Then we'll set the key property to be whatever we passed into the function, and then we'll set its previous and its next pointers to null. Okay. Now in the future, it might be helpful for us to kind of print out a node. So here is a helper method that I created called print node. What it does is it takes a pointer type called node as input to this function, and if that thing is null, it just prints null to the screen. Otherwise, it's just going to print its key property. Okay, pretty simple here. So that's kind of how we can test those things out. So let's see if we can test some of these things out. Okay, and then let's go ahead and print out these nodes. Let's see if it works. Cool. Let's open up a terminal. I'm just going to use the C compiler that comes with Apple for this. Okay, cool. So compiling it gets us this a.out file, and we can see that it prints the two nodes to the screen. Awesome. Okay, so now let's do the same thing that we did for create node. Let's create a list. So I have a method that I wrote for this called create list. Let's see what that does. So this thing is going to return a pointer to a list. Okay, and so the first thing we're going to do is create a variable of type linked list pointer, allocate some memory for that guy, set its head property to null, and then return that pointer. So pretty simple. And so we could test this. Let's get a print list helper method. And let's see what that guy does. So to print a list, we're going to first create a new variable called x. That's going to be of type node pointer that starts at the head. While x is not equal to null, we're just going to cycle through that. We're going to point it to the next value. But first, we'll just print out the value of the key. So once we print out the value of the key, then we'll just point it to the next thing in the list. Once this thing is pointed to null, then we'll just, return success. Okay, so that's the two helper methods. Let's talk about some operations. All right, so we have create list. Now what we need to do is we need to be able to insert something into this list. Okay, so I'm going to create another method called insert key. What insert key is going to do is it's going to return a linked list pointer. So the first thing we'll do is we'll create a variable called x that's going to be of type node pointer. And so the way I've implemented this here is you're just going to pass in an integer, and then this method is going to create that key for you, or that node for you. So let's look at the code for create node. I think I'm already, right? So we already have that method here, right? So we'll pass in that value, that integer, and create a pointer and store the return value of this as a pointer to a node. And then we'll implement how to insert this. So if the head of this linked list is not equal to null, we'll have to follow the pointer to head, then follow the previous pointer to head and set that value as our new node. And then regardless of the other two, or regardless of this condition, what we're going to do is we're going to set the next value to be head. Then we're going to set its, we actually don't need to do this. Previous is null, right? Because we're setting that in the create node method. So all we need to do is set the next value as head, and then set the head to be the current value of, or the set head to be the current, set head, make head point to the current node, this new node that we just made. Ugh, that's hard to say. Okay, so that's insert. Should we test it out? Let's test it out. So let's create a linked list pointer called list. Let's say create list, like that, and then we'll say insert key. We'll pass in the pointer. We'll pass in a value for the key. And then we could print this list. Let's see what happens. Compile, an error, insert key, looks like a insert key. What's the problem? Oh, I spelled it wrong. Okay, compile, and then let's run it. Cool, and it prints out 2, then 1, because it starts at the head. We always insert at the head, so the last one to insert was the head of this value, kind of like a queue. So then we print 2, and then we print 1. Perfect. All right, now let's think about how we can search for a key. So the return type of search should be a node pointer. Okay, so the first thing we'll do, and similarly this, the signature of this function is very similar to insert key. We pass in a pointer to a list and a value, and we were going to return a node if we find it. If we don't find it, we're not going to return anything. So here we go. We'll start at the head. While x is not null, while head is not null, well, where it starts at, and while the key is not equal to this value, just cycle through point x to the next value in the list. Once we break out of this loop, we'll just return x. So x will either be the value that we want, or the node, a pointer to the node with this key, or it will just be null. So we've inserted, let's insert a few more in here. Okay, so we'll print out this list, which should say 4321, and then we will search. We'll say node pointer node equals search. What do I call it? Search key. Search key, and we'll search for 3. And then we'll use our handy dandy print node function, and we'll pass a pointer of node into there. Cool. Oh, search key, we actually have to pass in the value of this, or the value of the little list, right? Cool. All right, so it prints out the list, and then it looks like it found the list. Now, if we pass in a value that doesn't exist in the list, it's just going to print out null. Awesome. All right, so that's search. We just kind of cycle through until we find it. Now we're going to try to do delete. So let's take a look at delete. Grab delete from my notes. Okay, so delete will mutate this list and return a pointer to it, right? So the first thing we're going to do is set a reference, a node pointer reference, to the key that we're trying to find. And that's going to use this method that we just found, or that we just defined, called search key. If a pointer to that returns null, then we'll just say that, hey, we couldn't find it, this key doesn't exist, and then we'll just return the pointer to the list. Okay, so just kind of some initial type checking, make sure that the key actually exists in the list. Next, what we'll do is we'll kind of move these pointers around to manipulate what we need to do to splice out X from the list. So we just kind of point the head to the next value, as long as it's not, null. And then otherwise, this would be head anyways, right? But we'll just follow the pointer to previous, then follow what previous is pointing to, and then we'll point that to the next value. Okay, we don't need to worry about the tail for this implementation. So now if fx.next is not equal to null, because if it is null, we don't need to do anything. We don't need to move any pointers since its values is already there, right? Let me think about that. Yeah. So if it is null, then we're going to move that pointer, the previous pointer, right, to where we want it, which is going to be following the current position of the node that we found, follow the next, then take its previous pointer and set it to whatever x.next was. And that way we kind of splice it out of the linked list. Okay, so let's try this. We'll call delete key. And we'll delete, let's try to delete 3. And then we'll print the list after we delete it. So we should see, actually, first we want to see the list being printed, and then we want to delete it. And then we'll print it again. Compile it, run it. So first the list had 4321 in it, and then it looks like we deleted 3 successfully. That's awesome. Now let's make sure it works when we delete the head. Awesome. And let's make sure we can delete the tail. Awesome. Looks like it works. So there you go. That's kind of how you can implement a linked list using the C programming language. I hope this video was helpful. We covered 4 major operations of the linked list. We handled creating the linked list, allocating that memory, and setting the head equal to null. We then handled the 3 operations: insert, delete, and search. So I'll post the code for this, and I'll put the link in the description. I hope this was helpful. Send me like and subscribe, whatever you like. Party on. Till next time.